Today we are looking at triangles and learning a couple little properties. So I just used GeoGebra to make kind of a random triangle. We're going to measure the angles together real quick. So when measuring an angle, find the measure angle tool. I can either click the two sides of the angle. That will bring up the angle measurement, or if I wanted to say measure angle B. B has to be the middle vertex that you click so that it knows that B is the center. Okay. Or you can just do the two sides again. Okay, so I've got my 3 angles measured. So every triangle has to have 3 angles. If I go over here to the calculator tool, it's got my three numbers for my 3 angle measures. It named them with these Greek letters, so we're just going to add them together. So if I say equals, where are we here? And then I add those 3 Greek letters, okay, alpha, beta, and gamma. It says that it's 180 degrees. So this triangle right here is 180 degrees. And if I use my mouse tool and I move a vertex, notice that these 3 angle measures are all changing. So we could make it an acute triangle. So every single angle is less than 90 right now. That's called an acute triangle. I could adjust it until I get a right triangle somewhere. Let's see if I can get it perfect. It's hard to make a perfect right angle without using the actual tools, but roughly a right angle here, just slightly over 90. But what's not changing is the sum. The 3 angles together are still 180, regardless if it was a right triangle, an acute triangle, or we could drag this even further and make it a very obtuse triangle, meaning we have an obtuse angle. In any case, our sum is 180. So that's the first thing that we want to make sure we have down. That is just a fact of all triangles. In every triangle, the angle measures add to 180, and we call that the triangle sum theorem. Okay, so the first thing in terms of classifying triangles that I want to go over is how we could classify them by angles. And we've already been talking about this a bit this year. So the first classification is called an acute triangle, and that's where all the angles are less than 90. Now we just learned that all the angles have to add up to be 180, which would be the case here, but the 3 numbers add up to 180 and individually are all smaller than 90. That's your acute triangle. The one we've worked with a lot already is a right triangle. Okay, so again, all the angles must add to 90. So we already have 90 used up here. Add to 180. So we already have 90 used up. So our other 2 angles, the 2 acute ones in our triangle, must be complementary, must add to 90. And our third option is an obtuse triangle. So if you're classifying by angle measurements, you either have all acute angles, we have 1 right angle in our triangle, or 1 obtuse angle. Okay, so these are your 3 classifications by angles. Next, I want to go over classifying by sides. Okay, so when we classify by sides, we're no longer really worried about the angle measurements. We're talking about the side lengths. So if none of the sides are congruent, okay, no congruent sides, we call it scalene. Okay, so every side length is a different number. No congruent sides, scalene. Next up is called isosceles. Now this might be a review for you, but an isosceles triangle means that you have 2 congruent sides. So in this diagram, those 2 lengths of 7 are equal to each other, and that makes it an isosceles triangle. Lastly, we have an equilateral triangle, where you have 3 congruent sides. Okay, so these are all classifications that I want you to be familiar with. Today we're going to talk a little bit about some vocabulary of the isosceles triangle. So here is an isosceles triangle. I'm going to say that these 2 sides of the triangle are congruent. We call the congruent sides the legs. Okay, we got 2 legs. The angle between the legs is going to be called our vertex angle, which is across from or opposite from the base. Okay, so your legs are the congruent ones, and then the base is what connects the two legs together. These angles right here that touch the base are called base angles. And there's a fun fact about these. Okay, your base angles, notice the base doesn't have to be at the bottom. A lot of times we might see our isosceles triangle where the base maybe is what it's kind of standing on, which is fine. But in any isosceles triangle, there is a theorem that the base angles, those two angles that come off of the base, are congruent. Base angles are congruent. So we know every triangle has a sum of 180, the triangle sum theorem. All three angles must add up to be 180. So let's say that I told you that this angle was 40 degrees right here. We could find out the measure of the base angles. We could start with our idea that base angles are the same, so we could call them each x. They're both the same value. We don't need two different variables because they are the same. And we can use the idea that the three angles together, 40 plus the x plus the next x, has to equal 180, and then we could solve for those base angles. Subtract 40 to the other side, combine our two x's, okay, kind of did two steps into one there, and our base angles would be 70. All right, so we're going to be using this idea that base angles are congruent and that a triangle has a sum of 180 throughout this unit. All right, so we have a few questions for you to practice these ideas. Here's number 1, classify this triangle using both angle measure and sides. So you're going to be checking 2 of the boxes. Here's number 2. Same question, go ahead and classify this one by both angles and sides. Okay, number 3 is a true or false question. Go ahead and read it there. And number 4 is asking you to solve for x. So to go over this one, because we see that this is isosceles, these would be what we call our legs. And then this would be our base. The angles that touch the base, that come off of the base, these angles right here are congruent to each other. So we also know that this angle here is also 30 degrees. So the 3 angles in our triangle, 30, 30, and x, together have to make 180 using that triangle sum theorem. So we can simplify this, and we find when we subtract that x is 120 degrees. All right, great job. We're going to be incorporating this into all of our lessons this unit. If you have questions on it, please reach out.